Welcome dear learners, this is Aishwarya, Assistant Professor, Department of Chemistry, St.Josephs College of Arts and Science for Women also. In this video we are going to discuss about isomerism. Isomerism in coordination complexes. So what is the isomer? The isomer is the compounds having the same molecular formula but different structure and hence different physical and chemical properties are called isomer. The phenomenon of the existence of such compound is known as the isomerism. Isomerism in coordination compounds may be divided into two main groups. First one is the structural isomerism, another one is a stereoisomerism. The structural isomerism have the 5 types. The first one is the ionization, another one is a hydrate or solvate isomerism, next one is the linkage isomerism, then coordination isomerism and ligand isomerism. In the stereoisomerism, it has the 2 types. The first one is the geometrical, the second one is the optical. The geometrical isomerism are also called cis-trans isomerism. Optical isomerism are called the mirror image isomerism. The structural isomerism. So structural isomerism defined by the coordination compounds have the same chemical formula but arrangement is different. So it has the 5 types. The first one is the ionization isomerism. It arises from the position of group within or outside the coordination sphere. These isomers give different ion solution. It is named as ionization isomerism. There are 2 distinct compounds of the formula of cobalt. One of them is a red violet and gives the precipitate with barium chloride, indicating sulfane ion is outside the coordination sphere. The second one is the red and does not give the precipitate with barium chloride but gives a precipitate of silver bromide with silver nitrate, indicating that now bromide ion is outside the coordination sphere. Next one is the hydrate isomerism. This type of isomerism arises from replacement of a coordinated group by water of hydration. The standard example is chromium trichloride, which can have the 3 distinctly different crystalline compounds. The first one gives the violet color, second one gives the blue to green color, then third one is the dark green color. The action of silver nitrate solution on these isomers indicates that they have 3, 2 and 1 chlorine ion respectively outside the coordination sphere. In the coordination isomerism. This type of isomerism is observed in the case of compounds comprising the both cationic and anionic complexes. This type of isomerism is also shown by compounds in which metal ion is same in both anionic and cationic complexes. Next one is the linkage isomerism. In some ligands, there are 2 atoms which can donate their lone pair. For example, in NO2 ions, the nitrogen atom as well as oxygen atom can donate their lone pair. They give rise to isomerism. If nitrogen donates a lone pair, one particular compounds will be formed. For example, thiocyanate isomer and isothione thiocyanate isomer. If metal and there are 2 examples, one is the nitro isomer, another one is the nitrito isomer. Next one is a polymerization isomer. This type of isomerism is found in those complex compounds whose formula appear to be a polymers of some simple complex compounds. So these complex compounds have the same ratio of different metal atom and ligand in them. Then last one is the coordination position isomerism. This type of isomerism is exhibited by bridged complexes and result from different placement of ligands. These are the example for the coordination position isomerism. The next one is the stereoisomerism. Coordination compounds which have the same chemical bonds but have different spatial arrangements are known as the stereoisomer. It has divided into 2 isomers. First one is the optical isomerism, another one is the geometrical isomerism. So geometrical isomerism also called the cis-trans isomerism. So geometrical isomerism is due to ligands occupying different position around the central metal ion. The ligands occupy position either adjacent to one another or opposite to one another. So these are referred to as the cis-trans isomerism. This type of isomerism is also called the cis-trans isomerism. So these are the cis and trans form of geometrical isomerism. So geometrical isomerism, so we already discussed, in metal complex ligand may occupy different types of position around the central metal atom, which are either adjacent to each other, cis isomer, or opposite to each other, trans isomer. So geometrical isomer is also known as the cis-trans isomerism. Geometrical isomerism is very much common in coordination compounds for coordination number 4 and 6. Isomerism in coordination compounds, iso is a equal, meso is a parts. So geometrical isomerism is very much combination is coordination compound for coordination number 4 and 6. This is example for the coordination number 4. And these are the example for the coordination number is 6. So next one is the optical isomerism. This isomerism, which forms a non-superimposable mirror image, is known as optical isomer or enantiomer. There are two types. The isomer that rotates the plane polarized light towards the clockwise direction is the dextro or DR plus isomer. The isomer that rotates the plane polarized light towards the anti-clockwise direction is the levo isomer or L isomer. The equimolar mixture of D and L isomer is known as the racemic mixture. These are the isomerism in the coordination complex. Thank you.